Hi everyone, welcome to Math 70. This video lecture is section 5.4. It's about simplifying rational expressions. So a reminder, what is a rational expression? Well, a rational expression has a division. That's basically what we mean. Examples can be 2/3, where it's all numbers, or it can be x over 7, where there's a variable in the top. It could be 9 over x, where there's a variable in the bottom. It can involve some additions in the top and the bottom. And it can involve powers. So it could be like x squared plus 6x plus 9 all over x squared minus 25. And if you think back to the previous video, see if you can factor the top and if you can factor the bottom using our special cases. So these are all rational expressions. And sometimes we can simplify. In this case, simplify means combine like terms and reduce the fraction, if possible. But before we get to simplifying, we need to talk about what values can go into rational expressions when they involve variables. So let me start with an example. And I'm going to start actually before my rational expressions. What values can go into the expression x plus 1? What I'm really asking is, if I pick a number, can I add 1 to that number? And the answer should be yes, no matter which number I choose. So no matter which value of x. If I pick 10, 10 plus 1, that's not a problem. If I pick negative 19 plus 1, not a problem. If I put 62 over 7, I can add 1. That's not a problem. What about if I have a rational expression? What values of x can go into the expression 1 over x minus 3? Whenever you see a question like this, you should be thinking, what are the possible mathematical rules that could be broken if I pick the wrong, I'm going to put that in parentheses, with the wrong, or quotation marks, with the wrong x. So there are generally two mathematical rules that we don't break. We don't take square roots of negative numbers. And we don't divide by 0. These are the two possible math rules that could be broken if we pick the wrong x. So let's try x equals 10. That's 1 over 10 minus 3, which is 1 over 7. That's fine. Nothing wrong with that. Let's try x equals 0. That's 1 over 0 minus 3. That's 1 over negative 3. That's fine. Let's try x equals 3. That's 1 over 3 minus 3, which is 1 over 0, and that is a problem. because we cannot divide by 0. So what values of x can go into this expression? Another way to say that is, what are the values of x that would break this expression? And the values that would break this expression are x equals 3. Let me give you another example, and then we'll write this down as a general rule. I'm not going to worry about square roots right now because we're focusing on rational expressions. Let's do x plus 7 over x minus 1 times x plus 4. Right? That's a rational expression because there's a fraction and it happens to have variables. And let's test some different x values. Let's try x equals 10 again. That's 10 plus 7 over 10 minus 1 times 10 plus 4, which is 17 over 9 times 14, which I really, if I want to work it all out, that's going to be 17 over 26. Nothing wrong with that fraction. Let's try x equals 0. That's 0 plus 7 over 0 minus 1 times 0 plus 4, which is 7 over negative 1 times 4, which is negative 7 over 4. Nothing wrong with that. Let's find a problem number. Let's try x equal 1. That's 1 plus 7 over 1 minus 1 times 1 plus 4, which is 8 over 0 times 4, which is 8 over 0, and that is a problem. X minus 1 in the denominator of my fraction means that if x equals 1, I have a problem. Let's try x equals negative 4. That's negative 4 plus 7. I know you can't see the original expression, but I've done it enough. Negative 4 plus 7 divided by negative 4 minus 1 times negative 4 plus 4. That's a 3 over negative 5 times 0, because negative 4 plus 4 is 0. That's 3 over 0, and again, that's a problem. So in general, any x that makes the denominator 0 is a problem. Otherwise, everything's fine. You might look at this expression and think, well, could there be a problem if the top is 0? So let's find out. I'll rewrite it. My formula was x plus 7 over x minus 1 times x plus 4. And so let's try x equal negative 7. That's negative 7 plus 7 over negative 7 minus 1 times negative 7 plus 4, which is 0 over negative 8 times negative 3, which is 0 over 24. 0 divided by a number is 0. That's not a problem. That's fine. So numbers that make x values that make the top 0 are not a problem. All right, we're ready to write down the general rule. Let's see how I want to write this. Okay, so for a rational expression involving a variable, I'm going to use x, but it could be m or p or z involving a variable x. The problem values for x are any values that make the denominator, the bottom, equal 0. Now your homework, it doesn't talk about problem values, it talks about acceptable values. Therefore, acceptable values for x are all numbers except values that make the denominator 0. That's just another way of saying the same thing. Let's do an example. We'll do a couple. Let's look at x squared minus 3x minus 10 over x plus 2 times x minus 7. So the acceptable values are all numbers except x equals -2 and x equals +7. Because if x is -2, I'm going to have a 0 times a number, which is 0 in the denominator. And if x equals 7, I'm going to have 0 in the denominator. Let's do another example. X squared minus 3x minus 10, all divided by x squared minus 5x minus 14. And now my denominator is not factored, so it's hard to tell what values of x would make the denominator 0. So our first step is just to factor the denominator. And I'll use the box method for that. Well, first I'll check. 14 is not a square number, and there's extra pieces here, so it's probably not a special case. So I'll use the box method. X plus, I'm going to have an x squared, and I'm going to have a -14, so I need two numbers that multiply to be -14 and add to be -5. So let's see. -13, +13, -5, +5. This one right there. +2 and -7, so I have a 2x and a -7x. I have an x plus 2 and an x minus 7. So my rational expression is equal to x squared minus 3x minus 10 over x plus 2 times x minus 7. And I picked this one specifically because we already know what the problem numbers are. Acceptable x are all numbers. Oops. Acceptable x are all numbers except x equals -2 and x equals 7. All right, you know what? Let's go ahead and factor the top of that expression as well, just because we can. If I were to use a box method on this, I would find out that it's x minus 5 times x plus 2. And the bottom is x plus 2 times x minus 7. And I want you to notice x plus 2 appears in the top and the bottom, which means that mathematically I could reduce this fraction by canceling the top x minus 2 with the bottom x minus 2. This would be the simplified fraction, but it does not mean that x equals -2 is allowed. X equals -2 is still not allowed. Because the original fraction, the original expression, has an x plus 2 in the top and the bottom, which means I would have 0 over 0, and 0 over 0 is still not allowed. Let me do another example, because I kind of ran out of room, so I'm going to pick another example. Let's look at x squared minus 3x minus 4 over x squared plus 8x plus 7. I think this is going to work. Let's factor the top and bottom. I'm going to have when I do the box method, I'm going to skip forward, but you can check. I should have an x plus 1 and an x minus 4 on top. And I should have an x plus 1 and an x plus 7 on bottom. Now I have factored. This is fine. Factoring maintains the equality. But I know that x cannot equal -1 and x cannot equal -7 because that would make the denominators 0. This is true no matter how much canceling, how much reducing I do. X cannot make the bottom 0 before I do any reducing. So the simplified would then cancel the x plus 1s in the top and the bottom. And that is a useful skill because it makes your calculations a lot easier. But when you are asked about what are the allowable values, you still need to look at your original equation. And you're going to see some homeworks like that. All right, we're starting to get into simplifying, i.e. reducing fractions. Or simplifying rational expressions. So let's do a few more of those. I showed you ones where there are quadratics in the top and bottom, and you factor the top and bottom. Maybe we have something that looks like 4x cubed over, let's see, 8x to the 5th minus 14x squared. And we want to simplify. We still do the same process. We factor the top and bottom. Factoring is fine. Factoring maintains equality. It's when you start canceling things that you have to worry. So the top isn't really going to factor very much. I can just leave it as 4x cubed. And the bottom, I go back a couple chapters and I think about my greatest common factor. So let me do that work over here. 8x to the 5th, 8 is 2 times 2 times 2. And then I have 5 x's. And the minus 14x squared is minus 2 times 7 times x times x. And so I see I have a 2 and an x squared. So 2x squared is my greatest common factor. And then I look for my leftovers in the top and in the bottom. Don't forget that negative sign. So I can factor the bottom as 2x squared times, it's going to be a 4x cubed. Nothing in common with the top, by the way. I should have picked a different number. And then a minus 7 inside the parentheses. And now I can do some canceling in the top and the bottom because 4x cubed is equal to 2 times 2x cubed. Sorry, let me do that again. Let me just do this really systematically. I'm going to factor the top, which is 2 times 2 and then 3 x's. And I have a 2x squared, so that's going to be 2 and then 2 x's. And then I have the 4x minus 7 term, which is not going to factor anymore. So there are some x values that would break this expression. If x is 0, I'm going to end up dividing by 0. That would be a problem. And if I could solve this term, I would find that there are some x's that make this term equal to 0, but that's not as big of a focus for this example. So instead, I'm going to simplify. I have a 2 and a 2 which cancel, and I have two x's on the top and on the bottom, and so I end up with 2x over 4x cubed minus 7, and that's as simple as it's going to get. I'm done. All right, let's do a couple more examples. Let's simplify 63x to the 4th over 35x to the 7th plus 7x to the 6th. Combining like terms, there are no like terms because these have different powers. So instead, I'm going to do some factoring. Let me factor the 35x to the 7 and the 7x to the 6th. I'll do that over here. 35x to the 7 is 5 times 7, and then 7 x's. I'm going to get a little lazy and just write down x to the 7th. And then 7x to the 6th, well, that's 7x to the 6th. And so I see that I have a 7 in the top and the bottom. And I have 7 x's and 6 x's. So my greatest common factor is going to be 7x to the 6th. And my leftover in the top is going to be 5x. And I'm not going to have any leftovers in the bottom, so that's the 1. So 63x to the 4th is going to be 7x to the 6th times 5x plus 1. And now I want to do some cancellation in the top and the bottom. So 63 is 7 times 9, and I have 4 x's. And then I have a 7x to the 6th and a 5x plus 1. So the 7's cancel. And thinking back to our cancellation of variables, if I have 4 in the top and 6 in the bottom, that's going to leave an x squared in the bottom. And now I'm done. And let's do just one more example. Back to, well, let's do a mix of different types of factoring. Will that help? No. Let's just do one more example where we're going to factor the top and the bottom. X squared minus 25 over x squared plus 3x minus 10. And if I factor that, I'm going to recognize the top as a special case. 25 is 5 squared, so that must be x squared minus 5 squared, which is x minus 5 times x plus 5. And if I box method on the bottom, I would find it's going to be an x plus 5 times an x minus 2. So my acceptable values are all numbers except for x equals negative 5 and x equals positive 2. And that's going to be true even after I do this cancellation. Simplified is, let's see, I have x minus 5 over x plus 5 divided by x plus 5 times x minus 2. And the x plus 5s cancel on the top and bottom. I'm left with x minus 5 over x minus 2. This is the simplified version, easier to work with, but I still am not allowed to use x minus 5 even in this simplified version. All right, that wraps up the video. Thanks for watching.